Question number 13, J Advanced 2018, paper 2 from physics. The question is about photoelectric experiment. Okay. Before you read this question, I just want to show you this diagram. There is a discharge tube where there is a light incident, radiation incident on one plate. From there, electrons are accelerated towards the other plate. This is the picture that you need to have in your mind. In photoelectric experiment, a parallel beam of monochromatic light with the power 200 watt is incident on a perfectly absorbing cathode of work function 6.5. This is highlighted point perfectly absorbing cathode. A cathode is one veena completely photons absorbing completely. Work function 6.25. So you know that if the incident energy is greater than 6.25, then electrons will be emitted. For example, if the incident photon energy is 7.25, then subtract 6.25, then you will get 1 electron volt. This will become kinetic energy. This is the concept. This source in the power is 200 watt. The frequency of the frequency of light is just above the threshold frequency. Incident frequency, threshold frequency in the thottu mugalilana, so that the photoelectrons are emitted with a negligible kinetic. The incident photon and the frequency, threshold frequency equal aana, adonde kinetic energy. So light is incident on the plate, electrons are emitted but with a zero kinetic. Initial kinetic energy of the photoelectron 0. Assume that the photoelectron emission is 100% efficient. That is, 100 photons vannal 100 electron emit avum. A potential difference of 500 volt is applied between the cathode and the anode. The diagram 500 volt is applied. ഇവിടെ ലൈറ്റ് ഇൻസിഡന്റ് ആവുന്നു, ഇലക്ട്രോൺ എമിറ്റ് ചെയ്യുന്നു, ഇനീഷ്യൽ കൈനറ്റിക് എനർജി എത്രയാണ്? അത് 0 ആണ്. ക്ലിയർ അല്ലേ? Now there is a potential difference, so these electrons will be accelerated towards this end. So when they reach here, they will have a kinetic energy, and this kinetic energy accord will be equal to charge of the electron into potential difference. Clear? And they will collide on the wall. They will collide on the wall. A potential difference 500. All the emitted electrons are incident normally on the anode and are absorbed. So they go to the anode, they hit the anode, they get absorbed, they don't bounce back. So whatever momentum they had, they transfer to the wall and their own momentum will become 0. Suppose the momentum of an electron was mv while hitting, this will become 0 after hitting. So the change in momentum is mv. ഇത്രയും കാര്യമാണ് ഇന്ന് മനസ്സിലാവും. The anode experiences a force. Naturally, ഇങ്ങനെ ആൾക്കാർ വന്ന് ഇടിക്കുമ്പോൾ force experience ചെയ്യും. We need to find out the force. So let us start from the force. How to find out the force? Force is nothing but change in momentum by time. Rate of change in momentum by time. Okay. How to find out this momentum, how to find out this time, etc. Okay. How many number of photons are incident? Number of photons. Incident എങ്ങനെ കണ്ടുപിടിക്കുന്നത്? അത് കണ്ടുപിടിക്കുന്നത് incident per second. ഇത് കണ്ടുപിടിക്കാൻ പവർ ബൈ എച്ച് ന്യൂ ചെയ്താൽ മതി. ഇനി എച്ച് ന്യൂ എത്രയാണെന്ന് പറയാമോ? ഇവിടെ എച്ച് ന്യൂ എന്ന് പറയുന്നത് കൈനറ്റിക് എനർജി 0 ആണ്. അപ്പം ഫോട്ടോഇലക്ട്രിക് ഇക്വേഷൻ എടുക്കൂ. എച്ച് ന്യൂ മൈനസ് വർക്ക് ഫംഗ്ഷൻ ഈക്വൽ ടു കൈനറ്റിക് എനർജി അല്ലേ? സോ കൈനറ്റിക് എനർജി 0 ആണെങ്കിൽ എച്ച് ന്യൂ മൈനസ് ഡബ്ല്യു 0 ആയിരിക്കണം. അപ്പോൾ എച്ച് ന്യൂ എന്തിന് ഈക്വൽ ആയിരിക്കണം? വർക്ക് ഫംഗ്ഷൻ ഈക്വൽ ആയിരിക്കണം. വർക്ക് ഫംഗ്ഷൻ എത്രയാണ്? 6.25 ആണ്. So power is 200, 100% efficient by 6.25 electron volt. This is number of photon emitted per second. But this will be converted into joule. So I'll just write the equation here. That means either ഈ ഒരു ഇക്വേഷനിൽ യൂണിറ്റ് കൺവേർഷൻ നടക്കണം. So number of photons emitted per second എന്ന് പറയുമ്പോൾ n/t എന്ന് പറയും. n is the number of photon, t is the time taken. This is the number of photon emitted per second. This is p by h nu. This is 200 watt SI unit ആണ്. 6.25 electron volt SI unit അല്ല. 1.6 into 10 raised to minus 19. This is the number of photons emitted. Clear? Now, how many number of electrons are emitted? This is number of photons incident. I mean, see 100% efficiency photoelectron. So, number of photons emitted. Number of photoelectrons. Number of photoelectrons. Emitted per second എത്രയാണ്? അതും 200 divided by 6.25 into 1.6 into 10 raised to minus 9. Okay. Now, what is the momentum of the photon on hitting the wall? Change in momentum എങ്ങനെ കണ്ടുപിടിക്കുന്നത്? Change in momentum is given by root of, I'll tell you, whenever electrons are accelerated, momentum is given by root 2m into kinetic energy. And this is root 2m into charge into potential difference. And this is root 2m into E into V for an electron. This for one electron. Now, this will go and hit the wall and momentum will become zero. Momentum will become zero on hitting. So, what is the change in momentum of this photon? That is root 2m into E into V for one photon. One, not photon, one electron. One photoelectron. So for each photoelectron, this is happening. This is change in momentum. So what is the total change in momentum of all electrons? That is number of photons into root 2m into E into V divided by T. I'm sorry, we don't want T. This is total change in momentum. N number of photoelectrons are there into change in momentum 1 photon. So what is the rate of change of momentum? That is N into root 2m E into V divided by T. But this n by t we have already calculated. Now we are ready to calculate n by t. നമ്മൾ നേരത്തെ എഴുതി വെച്ചിട്ടുണ്ട്. n by t എത്രയാണെന്ന് നോക്കൂ. അതാണ് 200 by e term. So that can be written like 200 divided by 6.25 into 1.6 into 10 raised to minus 19. Clear? That is the number of photon per second into root of 2 into mass of the electron should be given. 9 into 10 raised to minus 31. This calculation into charge of the electron 1.6 into 10 raised to minus 19 into voltage is 500. Okay. This is the calculation. Now how do we get through this? Calculation with 3 but let us simplify this. You can see that there is minus 31, minus 19 and 2. Minus 31 minus 19 will give you minus 50. Minus 50 plus 2 will give you minus 48. Then the root eduttal namalku kittunnathu 10 raised to minus 24 into root of what is remaining? Remaining thing endha nokku 2, 9, 1.6 and 5. 1.6 into 5 will give you 8. 8 into 9, 72. 72 into 2, 144 under the root. And here you have 200 by 6.25 into 1.6 into 10 raised to minus 9. So this will be again നോക്കാം. -19 and -24 give you -5. Okay, and this square root of 144, this will give you again you have 200 here. No, see this thing, 1.6 into 6.25 will give you 10. 10 will cancel this to 20. So this is equal to 20 into 10 raised to -5 into root of 144 12. So it will give you 12 into 240, 24 into 10 raised to -4 Newton as the force. Why write like that? Because they are asking you the force is F equal to N into 10 raised to -4. So what is the value of N? N is equal to 24. So our answer is N equal to 24. I'll write N equal to 24. The calculation, the values are given so beautifully that you can easily cut this one. Properly chindichale, allenga aga confusion aanu. Okay, makale. Thank you for your time.